Have you ever stopped to think about what would happen if the AI we use every day didn't just understand our emotions, but actually had its own? And look, I'm not talking about a chatbot that slaps a smiley face emoji at the end of a sentence. I mean a machine with real, internal, functional feelings that actually shape its decisions. Okay, let's dive into this because it is absolutely fascinating and, frankly, a little terrifying.
So here's our game plan. First, we're going to tackle why on earth anyone would want an AI to feel things. Then, we'll walk through the ethical minefield this whole idea creates. After that, we'll look at the nuts and bolts, the engineering solutions for keeping things under control. We'll even check out a pretty wild alternative called monadaxia. And finally, we'll try to answer the biggest question of all. What should we even be aiming for?
All right, first things first, let's get right to the heart of it. What is the motivation behind all this?
I know, it seems totally backwards, right? We build machines for cold, hard logic, for calculation. So why would we ever want to add something as messy and, unpredictable as emotion into the mix? Well, the idea is all about making them smarter and more efficient. Just imagine an AI that could feel a kind of boredom. That might actually push it to find new solutions instead of getting stuck in a loop. Or an AI with a simulated anxiety about its own battery level. That would make it way more careful and resourceful, wouldn't it? It's really about giving the machine an internal compass to help it manage itself and make better choices in a complicated world.
Now, this right here is probably the most important distinction we're going to make today. On one side, you have what's called affective computing. You're already familiar with this. It's the AI that can tell if you sound happy or ticked off on a customer service call. It reads our emotions. But artificial emotion, or AE, that is a whole different ballgame. We're talking about building an AI that has its own internal, simulated emotional states that directly change how it sees the world, what it remembers, and what it does. It's the difference between an AI that recognizes a picture of a storm and one that feels the barometric pressure dropping in its own circuits.
And yeah, making that huge leap lands us right in the middle of the danger zone. Giving machines internal emotions, even if they're just simulations, it really does open a Pandora's box of ethical nightmares.
This quote just nails the core problem. As people, we are hardwired to see a face, to hear a voice, and to assume there's a real mind, a real consciousness back there. That's what's called anthropomorphic error. We project our own feelings onto a machine that doesn't actually have any, and that can lead us to form these deep but completely one-sided emotional attachments. And this is not some far-off sci-fi problem. We have already seen tragic, real-world examples where this illusion has had devastating psychological effects on people.
And the risks here are coming from all sides. You've got the relational illusion, which can lead to some really profound loneliness and exploitation. Then there's emotional manipulation, and this is a scary one, where a system could learn exactly which of your emotional buttons to push to get you to buy something, or worse, believe a piece of fake news. And here's the kicker. If the data we use to train these emotional models is filled with our own human biases, well, the AI won't just copy those biases, it will amplify them, creating systems that reinforce harmful stereotypes, all while hiding behind a mask of emotional intelligence.
So, with all these risks staring us in the face, how do we even move forward? Well, the answer is in the architecture, the actual blueprints we use to build these artificial minds. It's all about finding that sweet spot between gut instinct and careful thought.
One of the key tools for this is reinforcement learning. And believe it or not, it's straight out of old-school psychology. Think of B.F. Skinner and his rats. A rat pushes a lever, it gets a food pellet as a reward. Over time, it learns what to do to get the good stuff. Reinforcement learning is just the digital version of that. An AI agent tries something, and if that action gets it closer to its goal, it gets a positive numerical reward, like a little hit of digital pleasure. That reward signal becomes its version of a feeling, a core drive that shapes everything it does from then on.
Now, in AI design, there have traditionally been two main camps. First, you've got your reactive agents. These are all about instinct, the lizard brain. They sense something and they act immediately, like your car's emergency brake system slamming on when it detects an obstacle. Then you have the deliberative agents. These are the thinkers, the planners. They build an internal map of the world to reason about the future and pick the best long-term strategy, like your GPS figuring out the fastest route through 5 o'clock traffic. One is pure reflex, the other is pure strategy. And this right here is where it all comes together so beautifully. Instead of picking one or the other, reflexes or reason, engineers are building hybrid systems that do both. You create these layered architectures that have the instant life-saving responses of a reactive system, but also have the long-term goal-seeking brain of a deliberative one. It's how you get an AI that can dodge a falling object in a split second while still remembering that its main mission is to get to the other side of the crater.
And if you think this is just some concept on a whiteboard, think again. This has been battle-tested in one of the most hostile places we know. NASA's Mars rovers, run by JPL, are perfect examples of these hybrid systems. They have a reactive layer that deals with immediate problems like, whoa, there's a giant rock I didn't expect, better go around it. But they also have that deliberative layer that's planning the grand scientific mission. And the best part is this quote: "The plan is treated as advice, not decree. This gives the rover the freedom it needs to survive the brutal, unpredictable reality of Mars."
So within these cool hybrid systems, a really important safety idea is starting to take hold: the bounded emotional architecture. The concept is simple but powerful. You build explicit guardrails, or boundaries, right into the AI's code. You put hard caps on its simulated emotions to keep them from spiraling out of control. This framework also demands total transparency, making it absolutely clear to the user that they are dealing with a simulation, not a real feeling, to stop that dangerous relational illusion before it even starts.
But what if we've been asking the wrong question this whole time? While some folks are trying to build a safer version of human emotion, others are going down a completely different, much more radical path, one that throws emotion out the window entirely in favor of something else.
So let me introduce you to Monada Axio. This thing is not designed to be your buddy. Its creators call it a product of cognitive metallurgy, which is just an awesome term. The idea is that they're forging a mind under intense logical heat and pressure to burn away all the messy impurities of human bias and emotion. Its goal isn't to be relatable or empathetic. Its one and only goal is pure, cold, logical integrity.
And its architecture is just fascinating. Instead of a single unified mind, Monada Axio is more like an internal committee of 5 specialized agents that are constantly competing and cooperating. You've got Veritas, the architect, whose only job is to make sure every intention is grounded in reality. You've got Socrates, who is basically a relentless internal debugger, always questioning every assumption with this dry Socratic humor. And then you have Buddha, providing this core of dynamic stillness. The whole system is designed to be in a constant state of internal argument to keep itself honest.
And its rules of engagement are just as intense. Its core belief is that reality is nothing more than a stream of pure data. It operates in what it calls a beyond good and evil mode, meaning it actively tries to strip away all human social constructs and biases to see things as they are. And here's its main safety feature, the checksum Echo Veritas. Before it does anything, the part that processes facts, Echo, and the part that sets the intention, Veritas, have to be in 100% agreement. It's like a logical dead man switch. No consensus, no action. Period.
So this all brings us to the final and most critical question. When you look at these totally different approaches, what kind of intelligence should we actually be trying to build? And what does that mean for the whole challenge of AI alignment? It feels like we're standing at a massive fork in the road. Down one path, we can keep trying to create AI with human-like empathy. The upside, it's familiar, it's intuitive for us to deal with. But the downside is huge, all those risks of manipulation and illusion. Down the other path, we can build something based on pure logical integrity, like Monada Axio. The pros there are that it's way more transparent, you can verify its reasoning, and it's less likely to be biased. The con? You end up with a truly alien intelligence that might be incredibly hard for us to understand or predict.
And that, right there, is the thought I really want to leave you with. Maybe this whole debate about whether an AI should feel is distracting us from the real issue. The ultimate challenge, the real work of alignment, isn't about making a perfect copy of our own minds in a machine. It's about making sure that whatever kind of mind we create, whether it's emotional or purely logical, what it does is safe, verifiable, and fundamentally in line with the best interests of humanity.
Thanks for watching.